Okay, so now, so I want to start with a review of fraction, and some of you may not have had this. Now, the first thing about fraction is that, see, well, in some sense, I did not waste any time because the examples I gave pointed out basically what the problems are. The trouble with fraction is that if you don't know what a fraction is, how can you talk about it? You will have to agree on what a fraction is, and for better or for worse, you have to stick with it and try to explain everything on that basis. Because if not, look at what happened. There's a piece of pie, and then a rectangle, and then it's a bucket of water. It just goes on and on. You change your tune every 2 hours. Students cannot learn. That's a problem, right? So the need for a clear-cut meaning for a fraction is basically paramount. So without cutting a long story short, well, it depends on the number line, and so I assume you know what the number line is. But the number line, of course, is nothing but the positive x-axis. Well, the whole x-axis, but for today and tomorrow, we just look at the right side of the x-axis, so to speak. So you know that the integers here, the positive integers here, equal to 0. Now, I was actually a little bit shocked when I first started doing this. To say a fraction is a number, is a point on a certain point on the number line. Now, look, when you do analytic geometry in grade 7 or grade 8, I say 2/3, what do you do? I say 2/3, what do you know? The number 2/3? What do you automatically think of? Oh, yeah. So, when you went through school, it's automatic. This is what you do. And yet, when I tried to do this to teach for teachers, there was a big fight. But now, see, again, lots of things get easier because now you look at the Common Core. The Common Core would never say this is the definition of a fraction. When you read between the lines, that's exactly what it says. And in fact, if you want to understand the elementary standards in the Common Core better, read the high school portion. They somehow, don't ask me, the politics is convoluted. They say a lot of things about what elementary school teachers or elementary students ought to know in the preface to the Common Core high school standards. And so it's unmistakable. You read it and it says a fraction, a certain point on the number line. Right? So that's the background. The advantage of that is when you cannot begin to count the number of the advantage you have by doing that. For example, so I say 2/3, right? So 2/3, a number like 2/3. This tells you how many equal parts you divide what we call the unit segment. 0 to 1 is called the unit segment, right? You divide the unit segment into 3 parts of the same length. When we say equal parts, in the context of number line, would be in segments of the same length. The 3 indicates the bottom, or the symbol, indicates how many parts, equal parts, you're going to divide the unit segment. The top indicates how many of those parts you're going to take. Right? So, 1, 2. Always start from the left. So, you take 2 of them. So you get here. So now this is what they call 2/3. Now, so if you change it to what? 7/3. 7/3. Although our philosophy is that indicates how many equal parts you have divided the unit segment, and 7 is 6, 7 of them. So you just 1, 2, 3, 4, 5, 6, 7. So that's every fraction can be done this way. Now, the advantage of this, and as I mentioned, there's an uncountable number of advantages. One of them is what? So we mentioned that fraction at one point is some piece of pie, at some other point is some part of rectangle, and some other point is a bucket of water. All of that now on the number line makes perfect sense, such as, for example, 2/3. Let's not like 2/3. This is a very important thing. It's called the unit. If you specify what the unit is, then you interpret all the fractions accordingly. For example, unit is area of a piece of pie. You have a pie. You fix the pie. So area of a no. Sorry, I made a mistake. A given pie. So you have a fixed pie. You fix that. Then you can talk about how big it is. One is not the pie. Now that's something that please, if you're ever going to teach this, get it straight. In schools, textbooks, they say one is a pie. One is a number. One is not an entity. One is not a geometric figure. It's the area. When you understand that, then when you want to say you divide the unit into 3 equal parts, in this case, equal means what? Equal area. Equal area. That makes a lot of sense to children and not the other way around. That's why they have perennial confusion over what. Well, I'll give you in a minute, okay? So when you say area, so everything becomes in terms of area. So 2/3 then, well, you can divide it 2/3. Okay, so this is the most obvious way to do it. 1, 2, 3, right? So 2/3, then it's 2 of them. Okay. Now, obviously, I cannot do it precisely, but you can see that this could be a. Yes. That could be good. No, this is still narrow, fat over there. Everything will be good. Okay. Now, I don't know, I forgot what's in there. But if you don't say area, this is one of those standard mistakes students make. You say 1 is a pie. Right? So what's 1/3? So children would say, let's see. So they say, well, that's 1/3, that's 1/3, that's 1/3. Now, of course, I cannot do it very well, but you can get the idea that what I'm trying to draw here is what? It's a diameter where
it's been divided into thirds.
Same length here, right? So I'm dividing it. So what is that the student says this width, the same all over. And you're going to fault the student for lack of understanding when they say this is 1/3. What's wrong with it? Do you see anything wrong with saying this is 1/3? What could be wrong with it? You said equal part. Equal to a student is what? Equal width? No? Right? So that you have to be precise enough to pin down what you expect students to think. So say area, then it's wrong, right? When you say area, then you know that this is smaller than this in area. So this is not the 1/3. On the other hand, if you say 1, if 1 now is the volume of a bucket of water. I change the unit. Yeah? So not this. Well, in that case, then, what would 2/3 be? Take the amount of water, that's only 2/3 of the whole thing. divide the volume of the water, or what we call the capacity of the water, into 3 equal parts and take 2 of them. Then it's okay. So, am I clear about this? Yeah? And now, I don't want to write down. Suppose 1 is sort of this or that. Forget all that, but I say 1 is now the area of a rectangle. Right? Actually, that's probably the best model to use. Then, if I do this, okay, if I use this, 1 is the area of this rectangle. 2/3, we'll have lots of ways to do 2/3. That's 2/3. But the following is also 2/3. Same rectangle, right? You agree that's 2/3 or not? Yes? Now, so anyone who has ever taught fractions will know this is one of the things that children cannot get over with. Why is this 2/3? Because 2/3 to them is what? Either this or, well, you're supposed to be equal, okay? That or that, right? It's a shape. It's the shape that matters. Is it that? That's not 2/3 to them. When you say 1 is the rectangle, now, what do you mean? 1 is the rectangle. You don't say what it is, right? They just say the electron of the D. They say, well, that's a representation. That's because it looks like two pieces out of the 1. But you specify, we're not saying about the shape. We're talking about the area. Area. 1 is the area of that rectangle. Then, well, look at it. You are dividing the area into 6 pieces, equals 6 equal parts. You take 4 of them. Well, that's 2. Right? So a little precision would go a long way. And this is the beauty of saying a number line, using number line to design a fraction. Now you can reconcile all interpretations of fractions just by by defining your unit differently. There was no contradiction in it. But of course, so every logical argument you're going to make on the basis of the number line. And in particular, for example, the most important fact about fractions is we're going to have equivalent fractions. Yeah. Well, I'm not going to say it in the form and the notes. There's a very good reason why the statement of this so-called theorem. So theorem simply means is something that true, logically true, right? So I state it particularly, and I give you an explanation. If you want to read it, you can read it. There's a very good reason why in the book, in the notes, it's stated in that particular fashion. But right now, I'm giving a quick review. I don't want to go into that kind of subtlety. I'm going to state in the most naive form that you and I know, which is AN over BN is equal to AB, yeah, for all whole numbers A, B, N. And of course, it's not entirely correct because 0 is a whole number. So I should really, strictly speaking, that N is not going to be 0 and B is not 0, right? But after a while, we have good rapport, we understand each other perfectly, then I'll just probably begin to slip and just not bother to understand. So, alright? But until that point comes, I'll try to be careful.